All right. Good morning, everyone, and thank you for coming for the session for the hybrid as a stepping stone. My name is Malini Saxena. I'm a senior consultant with the AWS Public Sector. I help nonprofits, financials, and civil organizations in their migration and planning to the cloud. With me is Kirk Kern. He's the CTO of US Public Sector for NetApp. As many of you probably know, NetApp makes storage appliances and software that helps with the data management of hybrid cloud networks. Kirk?
Thanks, Malini. If anyone has ever looked at NetApp or had an engagement with NetApp in the past, Malini's right. We were a storage management company, right? Predominantly built systems that we would engineer ourselves and then go to market. But over the course of time and this transformation that cloud has brought us, we're actually looking at data management as a holistic change to what NetApp does and what the industry is doing. And so we've moved out beyond just building storage controllers now to one of a data management platform or framework that will span the on-prem data center, across data centers, and from data centers up to the cloud. And so today we're going to talk about this hybrid approach where you can start in your data center and migrate to the cloud, keep it in the cloud, shut it off if you're happy, or potentially move things around in real time.
So before we begin, I just want to let you know that this session is part of a 5-session series that the Public Sector ProServe team has prepared for you. So these sessions are really designed to guide you through your cloud adoption journey, and in my opinion, they are really fun sessions to attend. So if you can, please attend these sessions. They're out there on the board. So now this picture is a picture of a not-so-fun event, right? You probably recognize from this map. What do colleges in China, hospitals in UK, state police in India, and Russian central bank have in common? They were all attacked by ransomware last month, asked to pay up to get their data back. On a personal level, this can be hard. At an organizational level, this is simply unacceptable. And then there are natural disasters, which remind us of the same thing again. We need to have a business continuity plan. I think we all understand why this is important. So I go to various different customers as part of a consultant. What do my customers really want from a cloud storage, right? They want easy to scale up and down systems, things that they can manage alongside their current operations, cost effective, and then support a variety of use cases. And then, in your organization, you have various different kinds of data that's stored in different ways, and you want to get to a place where you can do all of that and extend that capability into the cloud without, making things complicated. So based on our experience, we see organizations can be at various different stages of the cloud adoption journey. Some of you are just getting started. You have a project or two that you're going to try out in the cloud, just isolated projects, just to get a feel for what it looks like. Others have a foundational core infrastructure already established in the cloud. And then some others are working for enterprise migration, getting their entire enterprise infrastructure into the cloud. And then once you're past that, you're in an optimization stage where you're all in and now optimizing for the new cloud-native applications, right? So as new cloud-native applications become more available, as new tools come up, you modify your existing footprint in the cloud to take advantage of those things. So the good thing is that it's not an all-or-nothing choice, right? So from the initial project phase all the way to the optimization, that can take a long time for organizations. In my experience, that typically takes about a couple of years for a medium to large size organization, right? For that time period, you would need to make sure that you are operational in both the places. You can coexist in the cloud and on-premise at the same time. you need to bridge the gap and connect and move data between one system and the other, right? So this is where many of my customers are in this hybrid stage, where they need help in making sure that they're operational, and while they are moving their infrastructure to AWS, they can still be operational on-premise. So this is where partners like NetApp can help. So Kirk, could you tell me more about how NetApp helps here?
Absolutely. Thanks, Malini. So customers' transition to the cloud can start in typically one of two ways. One is they go off, look at the application stacks, try and either pick those applications, move them directly to the cloud, or write applications anew in the cloud. We take a slightly different look at these migration efforts, and we think data is the core of these cloud transformation or migration projects, right? And so as our government and all of the other agencies and departments across the country are migrating to the cloud, we look at this as a digital transformation initiative, one where data becomes the lifeblood of this transformation project, right? And so at NetApp, we look at data in three different forms, or 3Ds as we call it. The first of which, data is always distributed. Much like that map that Malini put up, you find that there's multiple sites. Every organization has multiple sites, multiple locations. Data's coming in from different sources. It tends to be very dynamic, right? It's always changing. Think of IoT systems, handheld devices, taking pictures, satellite imagery, you name it. Data changes quite frequently, and managing that change rate is also essential as part of a cloud transformation or cloud migration project. And then finally, it's diverse. We look at data in multiple forms, multiple protocols, multiple different ways of accessing your data. So we're not here today to talk about a particular file type protocol, an object technology, or even a block technology. The idea is that data can show up in multiple shapes and forms, unstructured, structured, and any of these migrations to the cloud have to pick the best method of moving that data from your data center to the cloud and then ultimately operating on that data once it's in the cloud. Just to give you a little background on NetApp, if you're not familiar with NetApp, we're actually the #1 storage provider in the public sector space. We have both major share in terms of revenue as well as the number of petabytes under management. And so that gives us a unique opportunity to look at our public sector customers and help plot a course for our customers to the cloud, right? And so we've gone all in with AWS in terms of how we give those offerings, or how we make offerings to the public sector customers to consume our technologies. If you go to the Amazon Marketplace, there's actually 14 unique different products that NetApp makes and is available in the marketplace today, both available as a pay-as-you-go option as well as a bring-your-own license. And then within the core products that we build, right, our engineered systems that we continue to manufacture and sell for on-prem data centers, we actually have incorporated AWS interfaces in the major products that we actually manufacture and sell today. And we'll have 7 enterprise products that are out there in the marketplace that have either S3 interfaces or an ability to share data with Amazon natively in some shape or form. And we'll step through all those technologies as we go through this. So conceptually, we roll all this up under a big umbrella that we call the NetApp Data Fabric. The idea being that the data fabric exists in your on-prem data center, extends out to the cloud, and can also potentially extend to other cloud service providers as well. We also look at that as a stepping stone or bridge to building the next generation data center as well. The idea behind the next generation data center is that it's digitally focused, it's agile, it's dynamic, it has all those capabilities that I talked about, the 3Ds of data, and then, oh, by the way, it also gives you the power to harness hybrid cloud in the shape or fashion that you see fit.
So the primary use cases I see when I go to different customers in terms of backup, archive, DR, shared storage, and analytics. So what we are going to attempt today is Kirk and I are going to talk about each one of these and talk about solutions and best practices of doing that in a hybrid situation. So backup and archive is, I think, pretty clear. If you still have tapes that you store your data on, it's probably a good idea to move those off. AWS is obviously a good choice for storing your backups as much as you want, securely, durably, and reducing the cost and complexity of recovering from those backups. So that the use case, why we even need to do that, is pretty clear, I'm sure. when you go to AWS platform and try to do this, there are various different choices, like everything AWS, right? We have EFS for your file share. We have Glacier for cold storage, S3 for objects, which I'm sure many of you are already using, Snowball for quickly moving data in and out of AWS, Storage Gateway for storage tiering, where I see that used most, and then EBS, obviously, for persistently storing your data on your EC2 instances. Each of these support very specific use cases, and I've seen customers mix and match a few and try to experiment with a few options to see what makes the most sense for them. So what we need to really, when we are trying to talk about all these different choices, right, what I see the customers do is have various different methods that they develop for these choices. And if you are an organization who's looking to simplify, how do you move data to the cloud? This obviously is not how I see people move the data to the cloud, right? So you have choices. You can use CLI scripts, Python code, Lambda functions, which I see most being used to move the data. And then there are a bunch of open source tools that you can use to do the same thing. But it may be simpler to use a partner solution like NetApp, which I've seen customers use, so they can just simplify the overall moving of data to the cloud.
Thanks, Malini. So I guess that's my cue, right? Simple. So at NetApp, we've actually developed a product called the AltaVault. Think of AltaVault as a replacement system for your on-prem tape libraries. What it does is it integrates with your existing backup software products, takes in streams of backup data, full and incrementals, shards it up into data chunks, does deduplication, compression, and then encryption, all right? So everything has to be protected, and then sends that out of your data center in the form of an object. Actually, that object can be on-prem, right? So you can replace your tape systems with on-prem object repositories. But obviously, in the case of this session or this group, we think that the off-prem object repository in the form of Amazon S3 buckets is the optimal way to go, right? It clearly offers better cost advantages as well as better SLAs on the back end. So let's jump into it a little bit. So this is what the product looks like. This is called our AltaVault storage product. It actually operates in two modes, right? One in backup mode and one in archive mode. In the backup mode, it works with your traditional backup software providers, right? So we have a list here of all these software providers that are out there today. So if you've already got backup and disaster recovery orchestrated in your existing data centers today, we're talking about your primary and secondary data centers. The concept here is that you install one of these appliances, and it can be an appliance in the form of a physical appliance like you're looking at on the screen, or as a piece of software, right? It can actually run as a piece of virtualized software, runs in Hyper-V, also runs in VMware, and basically that creates your gateway out to your Amazon S3 buckets. We've got some interesting integrations that we've done beyond just an S3 bucket, however. We have API calls that will let you manage that flow of information once it hits that S3 bucket, right? So you can go to the Amazon S3 or Amazon S3 IA, and then you can also age it out to Glacier over time. So it offers a lot of interesting advantages. Now, one of the things that we have found with our larger customers is it may not necessarily have the bandwidth from their on-prem site out to the cloud in order to just sustain a full backup on a nightly rotation. And so we actually support the Snowball interface as well. So a customer who doesn't want to upgrade his comms interfaces but still wants to take advantage of the S3 bucket can literally get a Snowball from Amazon, place that into his data center. We'll stream that data into the Snowball appliance. You ship the Snowball appliance back to Amazon, and then your objects get uploaded into the S3 cloud. We think this is a fundamental step in moving to the cloud, right? So it's kind of the low bar to tick off. It's like, hey, I want to do cloud adoption. I want to start to use some of these cloud resources, understand the billing cycles, what it takes in order to kind of manage my data at scale in a cloud. You know, backup is a real easy workload to take advantage of. And then you'll see as we move into the subsequent slides that once you have your data in the cloud, it's a real interesting conversation to start to talk about disaster recovery in the cloud. Because if I've got all my data up there, hey, what can I use that data for? Classic example is, well, we can start to talk about disaster recovery solutions.
So I mean, for disaster recovery, yes, back to our point earlier about natural or man-made disasters, you have to have a business continuity plan. And in the cloud, it's so much easier to do as well. You don't have to go to a data center. You don't have to ship tapes. It's really all can be scripted if you want to. And you can set up your data application so it's secure, easy to recover, test that recovery if you want to pretty quickly. So it's all very easy to do and manage in terms of disaster recovery. So it's a conversation that I have with pretty much every customer that I go to, even if right now they don't have a DR plan. Let's talk about when we go to the cloud, what's going to be a DR plan, right? So when we have different systems, right, you don't want to have, for example, twice the cost. That's the primary concern I hear from the customers. Oh my God, if I'm going to have a DR, I'm going to have 2 sites that I have to manage. That doesn't have to be the way. Depending on what your application is and what it's trying to do, what its value is to your organization, what's your recovery time and recovery point objectives, you can go from different options. You can go just a backup and restore where you're taking a periodic backup of your system once a day if you want to. And then if you needed to recover, you recover from that site. You can have a pilot light environment, which I think is a very common scenario, more common than you would think, where people have a small instance in another region. And then if I ever needed to recover from that, I increase the size of that instance. So I go from a T2 medium to whatever is my production instance. And that way it's pretty quick to recover and have a standing up site without incurring a lot of cost. There's obviously time that takes there. There's warm standby, which is you have 2 systems, and if one goes down, you have a high availability warm standby that can take on very quickly. And then for your most important applications that just cannot have any downtime, even if an entire region goes down, you want to go multi-site, where you have 2 sites completely operational in 2 different regions. Even if an entire region goes down, you have the other region where your application is up and running. So it really depends on your tolerance for risk and tolerance for what your promise is to your business, right? So if you have promised that my website is never going to be down, then you're going to go to the multi-site. So as you can imagine, going from left to right here, the cost and complexity of implementing these systems increase. Taking a backup once a day is okay. It can be easily scripted. You can manage that. But as you keep moving to the right side, the complexity of managing that can be hard. So that's where, again, I think using partner tools can be very useful to manage that.
Okay, so for the engineers in the room, you probably looked at that AltaVault appliance and asked, well, why would I want to deploy an appliance or piece of software as opposed to using some of the native S3 interfaces that are in backup software? And it's less about the backup stream and more about what you do with the data when disaster strikes, right? And so NetApp is really focused on the disaster recovery aspects of this in addition to just pushing data out to the cloud. And so I'll walk you through 3 different forms of disaster recovery that we kind of see as a conceptual use of cloud resources when you're pushing backup data into the cloud. So the first of which is, think of this as a scenario where you have cold data. Disaster strikes in your primary data center. How do you recover with a cold data? Now, as your RTO and RPO scores become more critical, then you're going to start to investigate, well, how do I have a warm data solution, for instance, right? How quickly do I need to recover, right? That's your recovery time options. And so you don't necessarily just deploy all your backup data in the cloud. You may want to cache some of that on-prem. That's the reason you would use an AltaVault appliance, right? So we keep some nominal amount of data based on the size of the appliance or the amount of data that you apply to the virtual appliance, so that should you have a recovery event, the likelihood that your data is on-prem is very high, and so that recovery happens in seconds, right? And you're not streaming all that data back off the cloud or diving through a full to get to some of the incremental updates. It's all there on-prem and can happen quickly. And then finally, the last piece of this is for really, really hot data, one where you want seconds to from minutes to potentially seconds of recovery time, we can look at these hot data solutions that we have in play. So let me walk through some of the scenarios. We'll start with the AltaVault. We'll go to what we call this data fabric, actually make that real. And then from the data fabric, we'll show how you can orchestrate HA systems in clouds. So next slide. So this is a traditional disaster recovery scenario here. You've taken, you're using backup software. The backup software has gone through the AltaVault appliance. It's pushed all the data out to the cloud. Now a customer wants to take advantage of it, right? I don't want to necessarily do orchestration between my primary and secondary data center any longer. I've got a compliance requirement to shut down at least one or some number of my data centers in my enterprise. So why don't we look at using all this data that's in the cloud for disaster recovery, right? And so this is a concept now where you have all of your data that constitutes your operational systems in the cloud in the form of S3 objects. From there, you can actually spin up a virtual version of that same appliance along with a software, your backup software. It can then read those objects out of your S3 bucket and then start restoring your entire enterprise into a public cloud IaaS offering, right? Now that will take some time, obviously, right? So it's going to take some time to read back all that data from your S3 buckets, stream that into all of the different virtual machines or the Omni instances in Amazon, and then go back to operations. There's also a similar example where you go to 2 data centers. Like, so your cloud is your primary backup. You still have that secondary data center, and you want to restore all the data from that primary into some secondary data center and spin that up. Once again, your RTO and RPOs are going to be relatively high, probably on the order of hours to days to stream all that data back into your system and then respin all your apps. So there's a better way to do that, right? So this is the cold recovery, still tried and true, maybe good for archives or historical purposes, libraries, those kind of things. But as we go to a more near-time or more real-time solution, we look at warm solutions now, still leveraging that same technology. So rather than using backup software and doing full and incremental updates, NetApp has a capability called a snapshot. Think of that as a warm backup, right? So a snapshot is a point-in-time copy of all your information integrated with the application so you have application consistency. So it has a known recovery point. We can take, along with your applications and your data, pass all that out through the AltaVault appliance, hit an Amazon S3 bucket, and there it sits. When a disaster occurs, through a simple management interface that we have called Snap Center, we can orchestrate the reconstitution of all your data into Amazon S3, from Amazon S3 assets into EBS volumes, and those EBS volumes get represented with the same software that we're actually running in the data center on that engineered appliance on the left. Right? So this is an example of where we can take what was a traditional backup scheme, remove a lot of the costs of the external backup software, make it a warm or more active environment, and really start to embrace some of the dynamic capabilities that cloud enables you to do. And then the last part on the slide off to the right is that little S3 interface. So while you're up and running in the disaster center, you can actually continue to do your backups back through Amazon S3 into another bucket. And you can start to think about these cascading levels of disaster recovery, backup and disaster recovery now, because everything becomes virtualized. It's all software-based. It's an example of scripting and orchestrating, as opposed to doing the brute force efforts of moving tapes around and trying to keep these data centers in sync. Now let's talk about another technology that I'll call hot technology, right? So this really talks to the dynamic or the distributed pieces of data, right? So at least 2 of the Ds we're attacking here. The first part is the distributed piece. Have an on-prem data center. You want to mirror that data up into your primary data center in an active-passive configuration, right? So we will mirror that data from an on-prem data center into what is essentially the same thing as a storage controller that's running in the cloud, as a elastic compute instance consuming EBS volumes. What we also do is, let's say you have a file, 10 meg file. You change 4K in that 10 meg file. We're not sending the entire 10 meg of changes across the wire because data is dynamic. We're only sending those updated blocks, right? And so you can take advantage of this block level incremental updating engine as well, lowers your network requirements, keeps your consistency much higher rather than doing full and incremental backups of that 10 meg file. And then finally, the last part is we bring some extra features to bear here in terms of your ability to select what protocol you would choose, right? So we can support NFS, CIFS, or SMB, I should say. CIFS is really deprecated. So you can do SMB shares, iSCSI targets, and NFS. So now you have the ability to choose any of the local protocols that you're using in your data center in your cloud. You have POSIX compliant mechanisms now, so if you're running applications that rely on POSIX compliance, you now no longer have to go through a long migration or a testing initiative because we've got all the compliance, all the compliance features that it's on-prem in the cloud. It's a simple initiative to spin this up and start using the cloud resources. And then the next slide is what I'll call really, really hot availability, right? So you can move your data from on-prem out to an availability zone in AWS. We can also orchestrate the failover between availability zones. So in this case, you have an ability to tell which volumes on that system in AZ1 that you want replicated to AZ2 in the event that you have a failure in your first availability zone. The HA is actually orchestrated between the two ONTAP instances and your applications, and so you can actually start to take advantage of logical failover of applications from one AZ to another. We're talking about things like MS SQL, SharePoint, Exchange, the traditional applications that you run in your data center, now with orchestrated high availability running in the cloud.
So let's talk about the shared storage use case, right? When you're talking about a hybrid environment, I think this is a must-have. You have various different kinds of data sitting down. You have file-based data, you have block-based data, and you have different object-based data. And as just talked about, tiered storage then becomes a very important concept, right? You want to keep the hot data that your applications are currently using close to your applications, and then any data that's warm or cold, maybe you don't need to have storage arrays sitting down in your data centers to store that because you could tier that off to AWS, right? S3 as a object store is very, very popular, right? To share data between different applications, I've seen that happen a lot, or even between different users, or being used for analytics. If you're going to try to do this on a large scale, there is a lot of orchestration that needs to take place to make sure that everything is operating correctly. So I think the tools are great in the sense that they will provide you, S3 will provide you the high availability that you're looking for. Everybody will be able to access that, the durability. But as you start to move your applications into it, you would need to make sure that you can keep the processes simple enough for you to be able to manage that. And then cloud bursting is a term that I have seen a lot of customers use. And that's a capability for you to basically extend your hosting model, right? It allows your cloud to have additional capacity when you need it without having to make capital investment in another data center. So if you have a system that for a period of time it's only going to use X resources, but then on certain occasions it might use more and a lot more, like for a short period of time, that's where you can extend your existing data centers into the cloud and using those. So there are lots of use cases about how people have done that for file sharing or for image sharing, things like that. Again, we're talking about significant cost savings when we go through this model rather than trying to store everything or trying to purchase capacity in advance to make sure that we have enough just in case our website hits more usage than we expected it to. So you don't need to have idle storage arrays sitting, which you're only going to use on a temporary basis, if you have a way to extend really your data center from where you are to AWS. And now, to be able to bridge the gap between the new and traditional architecture, right, you need to have a simplified storage solution, which can make for an easier transition. So that's what we're talking about, is to be able to transition easily from your on-prem or to be able to extend that easily to the cloud. So Kirk, can you explain how NetApp can help with these use cases?
Yeah, thanks, Malini. So once again, you saw how in the backup and the disaster recovery scenarios, we talked about simplicity. We actually covered the 2Ds, right? The dynamic and the distributed aspects of this. In this case, for shared storage, we're really talking about diversity here, right? So the diversity on how you want to consume, how you want to manage your data is every customer's choice. And so we'll step through three different techniques on how NetApp is actually leveraging cloud resources from AWS for diverse data types and formats. So let's step into ONTAP Cloud. You saw a bit of information around ONTAP Cloud, how it actually can manage data from on-prem out to the cloud and across AZs in the cloud. It also has to be simple to use, right? And so when we build engineered systems and customers consume engineered systems on-prem, they tend to take some classes. They have to go through some fundamental understanding on how the product operates, understand the command lines, the GUIs, those kind of things. But when we go to the cloud, we can't expect every user that goes to that navigates to the AWS marketplace and checks out a version of ONTAP Cloud to understand anything about NetApp, right? So we had to obfuscate everything about NetApp and storage manage it and make it very simple and easy to use. So in terms of a file-based interface for cloud consumption, we have OnCommand Cloud Manager here. This is a screen snap of it. And it's a really, really simple and intuitive interface to use. It's unlike anything we've ever built in the past. And with that, you have complete ability to control your files, your file types, the file protocols you want to use within your VPCs. And then more interestingly, the orchestration of those AZ events as well as on-prem out to the cloud happens simply by picking up one of those clouds, dropping it onto another cloud. It presents another pop-up, says these are all the volumes on your source cloud. Which one of these do you want to replicate? 3 clicks, push the button, boom, you're done. You've instantly migrated your volume that contains all your VMDKs, for instance, or all your LUNs for your database, or the actual binaries in another volume out to the cloud, right? And so it's that simple and easy to use. In terms of block technology, right? So customers may want to consume blocks as opposed to worry about files. We've made that simple and easy to use as well. So all of our next generation storage arrays that are on-prem actually have an S3 block interface in them, right? So you're investing in, for instance, an all-flash array. You've made a substantial investment in these flash technologies, but what you find is you place data on these arrays after a week, 10 days, maybe a month. What you find is 80% of that data becomes relatively stale or cold, and you're paying a premium for all flash technology, and you're not really taking advantage of any of the IOPS or performance characteristics of your investment. So what has NetApp done at the block level, right? So all this storage is virtualized at this point. Your applications don't see any changes. The files still appear as if they're mounted to your file share, or the operating system see that as a file that's completely available for consumption. We take cold blocks, move them into an S3 object. Typically the size is around 4 meg, and we take those blocks, physically migrate them off of the array, push them up to the S3 bucket, and we now have the ability to do a warm tier from on-prem out to the cloud with all those file stubs still being in place, right? So to your users or your application, that file looks as if it's still available. It hasn't gone anywhere to him, but what fundamentally has occurred is those blocks are now sitting up in the cloud. And obviously on a read request, we'll migrate those blocks back in, and that customer will pay some nominal latency for migrating those blocks in, typically tens of milliseconds. And so the idea is that we can build massive file shares now that leverage the low-priced back-end S3 interfaces while still presenting a seamless block interface or file interface to our customers.
So this, I think, is really incredible in terms of what it provides for the customers, right? This is one of those things that's going to be really hard to do yourself or orchestrate trying to manage that. So it's really, I think, very useful for the customers to be able to do that at a block level.
Yeah, oh, yeah, and I probably didn't mention the simplicity piece of that.
Yeah.
You turn that on, there are no configuration parameters, right? It's a set it and forget it type of feature. So a lot of the SEs or engineers that I work with in customer shops say, well, yeah, I want to set the period and this and that. I'm like, no, this thing is automated and simplified. The idea is you turn it on, let the software do what it's supposed to do, and you just continue to consume storage or data management like you see fit. Okay, and then the last part is around objects, right? We've had object technology in the marketplace for almost 8 years now. Met with marginal success early on because I think a lot of customers didn't understand what objects were. It literally took Amazon, thank you AWS, for showing customers what objects can be used for. And so now I think it can open up an interesting conversation about customers who are managing large chunks of information, right? These objects tend to be fairly large in size, and they want to kind of bridge the gap between an on-prem object repository and then what they can get from the cloud. And this is where things get interesting. Back to the simplicity feature, the idea of at least our WebScale object repository is that it has an ILM policy engine. right? So in Amazon, you use API calls to manage where your data flows into and out of Glacier and IA and into your standard S3 bucket. The idea with an on-prem object repository that, when you place objects into WebScale, for instance, an ILM rule kicks in, and you can set it based off of ingest point, user, file size, file name, file type, all those kind of things. You can apply a policy to it, right? You set a default policy, which could just be a generic, hey, place it into 2 buckets. But fundamentally, you want that to be applied for just about any piece of data that comes into and out of this repository. So the idea now is you ingest your objects, you compute on them, you do whatever information production or analytics is required. And then over time, as that object ages out, it will automatically pull out or spool out to the Amazon S3 bucket, and then it'll go through its life cycle in the Amazon S3 interface as well. And so we think that this is a really interesting way how you can start to leverage, integrated, automated data management as opposed to trying to write these a lot of these scripts. And then fundamentally, we also apply that to data protection as well. So you can select to just make 2 copies of the object, maybe one in the cloud, one on-prem, 2 copies across 2 different data centers, or you can actually choose to shred this thing up with erasure coding and have some fundamental component of that object sit in one geo, a second part in the second geo, and the third part up in the cloud. That way any one of those 3 go down, you still have access to your object. So there's a lot of different and unique ways to do data protection as well.
So again, this goes back to our conversation about cloud bursting, right? So have the concept of lifecycle management policies, which many of you are familiar with on S3 and Glacier, and extend that over to your on-premise environment. And now you have a single concept, and now you can apply lifecycle policies to your on-premise objects, and then eventually to S3 objects, and then take advantage of the cloud as an extension of your on-premise environment. So I think that's very powerful. Now this is the picture of my universe. I am a data person. My background is in data primarily. And when I go to different customers—
Her data is not my data, by the way. She's an analytics person.
I'm an analytics person, that's right. So when I go to different customers, I get pulled into conversations around how do we manage data and how do I take advantage of now the cloud has given me the opportunity to store a lot of data. Once we do store it, what do I do with it? How do I manage this enormous amount of data that I've now collected? What use it is? How can I possibly make sense out of it? And many of you have seen a scenario like this, right? You have a lot of data. It's in a pile. And what you're trying to do is make sense of it. And I was a student of statistics once. I realized that there are various ways of looking at the same data, right? You can have it analyzed in different ways. How do I make sense of all this data that's sitting in an S3 bucket or in a relation database? How do I manage that? So a term where you may have been familiar with is called data lake. That's been used to describe how we can use a publisher and subscriber model where everybody in my organization that has data to produce and data to share is going to pour into this data lake all the data that they want to share with somebody else, right? So if I have my enterprise applications that want to share data, or if I have social media feeds that I want to take in, or I have logs that are coming in from applications, all of that can be put into one place by just publishing that. And then you can have secure policies put in there and permissions to really describe who can subscribe to this. And now what you're really doing is putting all your data in one place, and you don't need to duplicate this. It's in one single place, and then you can have different technologies like EMR or Redshift dig into the same data without making copies of it, really, and analyze it for different purposes. So if you have a BI application looking at it, you can do it one way. Or if you have a set of subscribers that need to download that information and use it for their own thing, they can make a copy. So the idea is that you can have all the data in one place without having to duplicate it, and then use this publisher-subscriber model where you can assign policies and permissions to see who can use it and how. And that really opens up your case for analytics in general, right? Now that I have a place to store any type of data at any scale, at a very low cost and in a central repository, now this opens up the ways to do analytics. Then again, when you're talking about this, there are considerations, right? If I'm trying to pour all this data into your earlier point, we have to look for bandwidth considerations.
You're saying
right?
It doesn't have to be an HDFS and a Hadoop cluster somewhere?
I would love it to be there. I'm just one of those people. No, but
SQL? Can it be in SQL?
SQL, yeah, I know.
Yeah. How about files?
I spent it, SQL is like just write a query, right?
Yeah.
You can query it all. And really, nothing against SQL really, because I have still seen like, tools are expanding to be able to query data sitting directly like Redshift Spectrum, query data that's directly in your S3 bucket and then join that with your data in the Redshift cluster. So the point is that we have to really look at all these tools and understand how we can make the best sense of it. When it comes to synchronization of your on-premise data with these tools, now that you understand that you can have all this value that you can derive out of it, how do we do that, right? So you have network bandwidth considerations, you have asynchronous or synchronous workloads that you're supporting. So we can't support, obviously, everything. We can't just push everything. So we have to be smart about what we push. So do I take an object and I have a file, every time it changes, do I copy the whole file? Or do I copy only a subset of what has changed? So we have to get smart about doing that. So do an initial sync and then copy over only the changes that can be done since the last synchronization schedule. So that's where I think the NetApp solution improves the speed and manageability and then allows customers to be able to take advantage for all this data that they have.
Mm-hmm. Okay, so I guess this is my chance. One of the things we looked at as part of sort of our data management or data fabric strategy was there's obviously some interesting services that are available, EMR, Redshift, RDS, for instance. We still have a lot of data on-prem. Customers may or may not want to move that data directly into the cloud in its existing form. And so this is a marketplace item that's actually available out there today. So you can navigate out to the marketplace, type in NetApp, you'll see CloudSync pop up. CloudSync is actually a service that has a foot in your on-prem data center and then one in your VPC. And what it does is think of this as a sync service with a file duality mode. And the idea is that every NFS file that exists in a storage controller on-prem, and it doesn't have to be NetApp, any NFS file share you have out there will create a relationship from that file to an object that sits up in an S3 bucket that's part of your VPC. And so we'll maintain what we call relationships, right? And so you can set up n number of relationships, whether it be directories or individual files, large files probably. And the idea is that we'll always keep that relationship from the on-prem file to the cloud object interface coherent and consistent. And then, so think of this as taking all your data. You've got data lakes of file-based information in this case. You want to create objects up in the cloud, so we'll push all that data up there. You can then read those objects with elastic map reduce, and so you no longer have to put everything into a HDFS file system in order to take advantage of it. You're basically reading all your objects natively in the cloud, and then as the data is produced, your answers, your analytics, what have you, it'll produce an object, and then we'll bring that object back home in the form of a file, so you can go off and do analysis on the data reduction that it actually occurred in the cloud. One of the interesting parts about this, though, is in some use cases when using this service, we've seen up to a 70x performance improvement by keeping the sync service as opposed to maintaining this sort of brute force, kind of RCP copy objects and files to and from the cloud.
So you're telling me that S3 is the center of the universe?
Yes, exactly.
I think so. I think I can agree to that.
Okay, and so we're kind of coming to a close here. We've got about 5 minutes left. And I just want to walk through everything, kind of summarize everything that's available in AWS today. I've given you hopefully an introduction to ONTAP Cloud. Think of that as our data management software that runs on our storage controllers, that runs now as an elastic compute instance in AWS. Multiple sizes and types are available as well. Available in every region across the AWS operational data centers. We're also available in GovCloud, and for our classified customers, also available in C2S. So feel free to navigate out there, give it a try. It's available as a 30-day trial. The AltaVault's available as a physical appliance or as a virtual piece of software running hypervised in your existing data center or in the cloud in the form of an instance as well. We typically use the instance-based version of that for disaster recovery purposes, but if you did want to push all your raw data over a network pipe into the cloud and then let the AltaVault instance do the compression dedupe, you can do that as well. We have some of these data fabric solutions now, which give you volume level granularity and let you control major chunks of your workloads or use cases into and out of the cloud. We've talked about the cloud sync service, right? So for people that are investigating analytics, might not want to put that entire data lake up in a big repository in AWS. You can selectively create those relationships of the files to objects and then do your computation in the cloud. And then finally, I think an interesting concept is for the on-prem object repository. If you become accustomed to managing data at the object level with the metadata, you can now start to take that next step into an information lifecycle management, managing objects in the form of policies, and now you've got very, very detailed mechanisms for controlling where your data flows, where it's stored, and then actually understand when and how those objects get moved.
So again, I've seen customers have various different kind of use cases when they're talking about storage solutions. So the idea of this conversation today was to let you know that it's not a one-size-fits-all. For your organization, you may choose to have a balance between what you do by yourself, what you use a partner solution for, what kind of solution do you use, because if you're using, NFS versus storage, like on an object base, what is the right solution for you? So our goal today was to give you all the use cases and the possible best practices and scenarios to be able to apply to your own environment.
Choose the way you want to manage your data at this point, what protocols you want to use, despite wherever it exists, right?
Exactly.
Okay, just a quick summary here. In terms of additional information, we actually run a microsite if you're interested in learning more about NetApp technology on AWS, so navigate over to netaponcloud.com. In there we have technical reports for a lot of the major workloads, SAP, Oracle, Exchange, those kind of things. Hold your question for 1 second, we'll take it. And there's also a way to go get test drives. It's available for 30 days free. You'll still have to pay the AWS charges for the EBS and EC2 instances, but our software is free for 30 days. If you want a larger trial, we can make that available. Contact your local rep. And with that, I'll let you do your part.
Go ahead.
Curious, ONTAP is available in the GovCloud, right?
Yeah, ONTAP is available in the GovCloud. Yes, sir.
And what's you have a physics rating? At what level?
It would be the moderate. GovCloud's moderate. So we inherit all the certifications that GovCloud has. So it would be ITAR and FedRAMP moderate.
Do you have a separate accreditation?
I'm sorry?
Do you have a separate accreditation?
We do not have a separate accreditation, no.
Any other questions we can take right now? This is just a link for the AWS white papers for the disaster recovery. These slides will be available for you guys after this, so this is a really good white paper. I find it very useful when it talks about different scenarios. And with that, thank you guys for attending the sessions. If you have any questions for us, let us know. Thank you.